Hello everyone. Today I'll be going over some fraction operations, and to start us off I want to go over some additions and subtractions for fractions. So let's get started. For our first part I want to go over addition. So let me give you an example here. Let's say I have 1/2. 1/2. So if you want to go into the concept of fractions, I encourage you to watch the video that I made yesterday. It was the introduction to fractions, and it's in the pre-algebra category. And it'll explain everything you need to know about fractions. But let's get started. We have 1/2, and then I want to add 1/2. So imagine this conceptually. If I have half of an apple, and my friend gives me another half of an apple, I'll have one full apple, right? I'll have 2/2 apples. What I did here was the denominator, the bottom part, did not change. However, I added the numerator, the top part. 1 plus 1 is equal to 2. Let me show you another example. Let's say I have 3/4 plus 1/4. The denominator doesn't change, but the numerator, I add them. I use the operation here and I add them. 3 plus 1 is 4. And as we know from before, 2/2 is equal to 1. 4/4 is equal to 1. Okay, what if we had a different sort of equation? Let's say we had 10/15 plus 3/15. That'll be 10 plus 3, which gives me 13 over 15. All right, so this is an example where the denominator is the same for the two fractions. So another example of this is, let's say I have 5/30 plus 16/30. The denominator is the same, so I can leave it as the same for the answer. 5 plus 16 is 21, so I have 21/30. Now, what if the denominator was not the same? Let's say I had 2/5 plus 7/10. Here, the denominator is not the same. So I can't just simply put whatever I want here. I have to make these two the same before I add the numerators. So what can I do to these equations, these fractions, to make the denominator the same? Since 5, I can fit that into 10 two times. I'm going to multiply the denominator here by 2. And anything I do to the denominator, I have to do to the numerator. So I'm going to also multiply the 2 by 2. Okay, now to rewrite this, now I have 2 times 2, which is 4, over 5 times 2, which is 10, plus 7/10. Now, since the denominator is now the same, I can rewrite it as 10 as the denominator of the answer and do the operation. Here I'll get 11. So I'll get 11/10. Simple enough. Let's do some more examples. Switch up the color here. Okay. What if I had, instead of simple ones, I'll do ones that don't fit together so nicely. How about we do 1/3 plus 2/5. So here 3 doesn't fit into 5, right? Let's rewrite this. I want to make these the same. What I'm going to do is multiply 3 by 5. Multiply 1 by 5. And then I'm going to do the same here. I'm going to multiply 2 times 3 and 5 times 3. Because in this case, I'm going to have 15 as the base for this one and 15 as the base for this one. because 3 times 5 is the same as 5 times 3. So here I'm going to have 5 over 15 plus 6 over 15. And that will give me 5 plus 6 is 11, so I'm going to get 11 over 15. It's as simple as that. Let's do another example. If I have 50 over, let's say 70 plus 20 over 70, I don't have to change anything because here the denominators are the same. So I'm going to get 70 over 70, which is equal to 1. All right, let's get into some subtraction. And the beautiful thing about subtraction when you're dealing with operations of fractions is that there is really no big difference. So subtraction. Okay, I'm going to do a simple one first with the same denominator, and we're going to see how we're going to deal with it. We're going to have 5 over 10 minus 2 over 10. Here, since the denominator is the same, we're going to have 10 as the denominator. And then the only difference between the subtraction and the addition is that the operation for the numerators, the 5 and the 2, is going to be subtracting. So here I'm going to do 5 minus 2. That's going to leave me with 3. So the final answer is 3 over 10. Let's do some more examples. How about we have 7 over 6 minus 3 over 6. All I do is rewrite the 6 as the bottom because the denominator is the same. Then I do 7 minus 3, which leaves me with 4. Now in this case, when I have 4 over 6, just as we saw in the Introduction to Fractions video, we have to simplify it because we can divide 4 by a number that we can also divide 6 by. 4 divided by 2 and 6 divided by 2. Here it'll leave us with 2 over 3. So that's our final answer. Okay, how about examples where the denominator isn't the same? How much different is it going to be? Let's do 3 over 4 minus 2 over 3. Since 3 doesn't fit into 4, and of course 4 doesn't fit into 3, I'm going to multiply the fractions by each other's denominator. So 4 times 3 and 3 times 3, since I have to multiply the denominator by the same number I have to multiply the numerator by. And here I'll multiply by 4, and I'll multiply by 4. This will leave me with 9 over 4 times 3, which is 12, minus 2 times 4, which is 8, over 3 times 4, which is also 12. And the whole reason we did this multiplying deal is so that we have the same denominator here. This allows us to then rewrite 12 as the denominator of the answer, and we do 9 minus 8, which leaves me with 1. Final answer, 1 over 12. Okay, let's do a bit more examples just so that we get the hang of it. How about we get 7 over 36 minus 14 over 70. These are larger numbers, right? And since 36 doesn't fit nicely into 70, it'll leave us a remainder. We have to multiply them into a number that they have in common. Now, since I don't have my calculator with me, I'm going to have to multiply them by each other. I'm going to multiply this by 70, this by 70, and this by 36, and this by 36. Okay, 7 times 70. What does that leave me with? So 7 times 70 is 490 over 36 times 70. 36 times 70, let's see here, we got 2,520 minus, and then we have 14 times 36, which is 504, over 70 times 36, which we found before, which is 2,520. Now, I simply have to do the subtraction. And notice here that this number is smaller than this number. This doesn't make a difference as to how we apply the rule. It simply means that our final answer is going to be a negative number. Okay, so first step, since the denominator is the same, I'm going to rewrite the denominator as 2520. Then, for the numerator, I'm going to do 490 minus 504, and that leaves me with negative 14. So negative 14, meaning my final answer is, well, not my final answer, but we can simplify it as negative 14 over 2520. Now we have to simplify it. So since these two numbers are pairs, I can divide them by 2, right? And another way I can do this is I can divide by 7, because here I know that this was divisible by 70. So I'll divide both numbers, the numerator and the denominator, by 7. So the first one I'll get negative 2 over, and then I get 360. And I can leave it as that. Or I can divide again, because I want to get it as simplified as possible. So if I divide by 2 this time, since I know that they're two pairs, I'll get negative 1 over, and 360 divided by 2 is 180. So my final answer is negative 1 over 180. All right. Now, if we want to multiply or divide, these are operations with different sorts of rules. And I'm going to be going over those rules in the next episode. Thank you for tuning in, and I'll see you next time.